Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench I have something a little different. Like I said before, I'll fix anything. And this is a ProPoint MIG100 little MIG welder. Now, this is a funny story. I was just outside washing my vehicle. It's a nice day in April. And heard a big bang. And my neighbor, next door neighbor Andy, plugged this into 240 volts. But it's only a 120 volt welder, so it went bang, let the smoke out. And yeah, he was in the middle of a big project. He's doing a bunch of welding for the farm and doing some fabricating, and this thing blew up on him, so he's kind of choked. But he asked if I could have a look at it, and yeah, I said sure, why not? I can look at it. It's all electronics, it's all the same. So this is it here. It's just a little welder. Let's have a look at it. So here's a tag, ProPoint. It's a MIG100. Yeah, it says on here, what does it say? 50-60 hertz, 110 to 120 volts, 26.5 amps. So yeah, kind of blowed it up. And if we have a look inside, you can see there's a couple big caps that let the smoke out. These are 2200 microfarad at 200 volts. I don't know if I'm going to be able to find those. I don't think I'm pretty sure I don't have them in stock, but we're going to have to replace it. And probably rectifiers, fuses, MOSFETs. There's probably all kinds of damage that's done in this thing. So I think the best course of action right now is just to get this main board out of the case. Looks like it's all connectors that I can disconnect. And it should be fairly straightforward. Once I get the main board out, we can work on it and get it working again. Yeah, unfortunately, that's what happened. So as you can see, it's a wire feed welder, and you can put flux core. This is flux core, and I think you can run gas on this too. I do see a nipple on the back here for gas, and it looks like they have the valve. There's a valve here, and this goes up to your torch head. So like I said, I'm going to get this board out and then we'll see what we can do for it. Alright, we got it out of the case, so now we can have a good look at it. So you can see those two caps are definitely gone. We're going to have to replace those. Yeah, and then I was looking at this. Power comes in on these two red wires. One red wire goes straight to the relay here, and the other contact to the relay, the pin's missing. I guess that's our fuse, because that pin is completely vaporized and gone, and that would coincide with that skid mark there that was opposite of this pin. So we're going to have to replace that relay. From the relay, it goes straight into this bridge rectifier, and let's check and see if that is kaput too. I'm guessing it would be. These two big traces here, yeah, these are our filter caps here, and these two big traces here would be our plus and minus. Goes into this inductor. Okay, so let's see here. This and this would be our plus and minus. This would be our ace. No, that's not right. These two are connected together. Anyways, let's just check. Oh, did I see something there? It's got a conformal coating on it, so that's open. That's open too, so maybe this diode is completely vaporized. Let's try this. Getting any readings on any of these. This is working. This conformal coating is really messing me up here. Hang on. Got to dig through it. Okay, there we go. Don't know if that's a diode drop there or not. Okay, that's a diode drop. And this should be open. But we're measuring something here. Okay, so let's check between this one and this one. And that bridge rectifier survived. That's surprising. Now we have the two caps are gone, and then we have some MOSFETs here. These look like MOSFETs, I think. Gate source drain, or is it gate drain source? I'm not sure. Let me see if I can measure something on these. It's not shorted. Might have got lucky here. Need some sharper probes. That's not shorted. This here is another one. That one's okay too, I think. We might have got lucky. It might have been just the relay and the two caps. So let me get these caps out, and let me get this relay out, and then I'll test. There's a couple more MOSFETs here. I think they're MOSFETs. We'll have to test everything because it took quite a bit of trauma. Okay, let's get the iron warmed up. And everything's got this silicon on it. Okay. All right. This here's the other side plate, and you can see it's got the white smoke on it from the capacitors. So it must have been a big flash bang. And yeah. Takes a lot of heat. Okay. I expect these holes are plated through, so it's going to be incredibly difficult to get these parts out. Better just to rock them out instead of using the solder sucker. Okay, I'll clean those holes later. Now we can start to see a little bit. Let's get this relay out. relay. Put the glue first. I can't see very good. Okay, that should help. Conformal coating really messes up. A lot of copper here too, so it sucks the heat away from the iron. There we go. There we go. Now I'll just get these two. Yeah, that pin's missing. I'll have to check these components here. There's 4 diodes, a couple resistors, and a transistor here. That might be kaput. So I think what they're doing is they're doing, well, this is the coil here. So this is the driver circuit for the coil. You got a transistor and a back EMF diode here. So that should be okay, all this stuff. Anything else that's connected to the mains though might be suspect. There's a transistor here. I don't know what this does. It might be like a voltage supply for all of this. Looks like they may have a little switcher supply here that runs this transformer that runs all this logic and control. So I'll have to check this, see if that is fine. That looks fine. It might be okay. So this is the first MOSFET I removed, and we're going to test it here. See what this says. This is a, let's see here. Yeah, it doesn't look good. Doesn't look good. Yeah. I think we got blown MOSFETs here. Alright, here's the second one I pulled out. Yeah, that's no good. 1 and 2, that's the red and the yellow. So that's those two. Yeah, these are 60 and 60 FD1s, insulated gate bipolar transistor. Field stock, whatever that means. So these are available. I might even have these in stock, I'm not sure. But my big concern is, how far did the damage go? And we have all this this elastic here with components underneath, surface mount components. I have to dig all this out, and because there could be dead components under here, little resistors or capacitors or something. Well, I don't think capacitors, but yeah. And then I'm going to suspect this bridge rectifier. I'm going to have to pull this out, and then there's 2 more transistors here I want to pull out and test. This is a lot of damage. But so far everything's available on DigiKey, so we should be alright. This might just cost the owner a little bit, but we're going to get her fixed, I think. Alright, got the bridge rectifier out. I'm going to test this one as well. So this is a, let's see, can you read that? It's a S35VB. There's our positive, so assuming that would be our negative, and this would be our AC. So our diodes would be facing this way and then this way, positive, so negative pin here. And we should get diode junction there. Diode junction there, but it's not the same. 514, 526, okay. 513. Yeah. This bridge is okay. I wonder if I should replace it anyways. It probably took a big hit of current. I'll see if I have any of these in stock. I probably do. If I do, I'll put a new one in. But that should be okay. There's no shorts. There's no opens. I'm just concerned that the diode drops, junction drops aren't the same. So it might have been stressed. And that's pretty much it. Everything else is okay. These 2 aren't transistors, these are rectifiers. Okay, you can tell by the way they're wired here. The center pin and then the 2 outside pins. So that tells you it's a rectifier. I tested, there's diode drops across these. These are fine. They're not open and they're not shorted. So yeah, everything else is checking out, except I have to dig out all this crap because there's components under here I don't know. There's a cap here, there's a diode here. I want to make sure that everything is good before I put new parts in here. And there's not something that's blowing underneath this. Okay, update time. So I've been doing a lot of work here behind the scenes, trying to figure out what actually happened, and well, not really what happened, but how bad the damage is. Now let me give it here. I removed these 2 transistors. These are insulated gate bipolar transistors. As far as I can tell, they're both open, so we can test those together and how to test IGBTs, and we'll do that in a bit. But I just want to talk a bit about this circuit here. Now, I was kind of scratching my head a bit at first, but then I did a big Clive, and what you do is for a circuit you can't really understand is you draw it out, you reverse engineer it. So here we got our line and load. A line comes in, it's got a 100 ohm PTC here, that's this thing here, and it's across the relay contacts. So this thing, when you plug it in, it's powered up. It charges these caps through this PTC, and then when you start welding, the relay contacts close and you get full power through. It's a simple circuit. They use the bridge rectifier as 2 half-wave rectifiers, and what they're doing is they're getting a positive negative supply, and these 2 caps here are the filters for that, and our neutral is our common. The 2 IGBTs are arranged in a push-pull fashion, and what they do is they push-pull on this transformer, and then this transformer is rectified, and that's our welding current right here, right? So, and then there's a feedback current transformer that's in the loop so they can monitor this. So this relay is controlled, and then this is monitored. This gate drive, this is what I was mainly worried about, is how bad the damage was. So I was trying to figure out if the gate drive was broken. I had to dig out all of this potting compound and to reveal these circuits. And the gate drive is actually this little transformer here. And as far as I can tell, all these components are okay. There's diodes, there's resistors, and a few caps, and they all check out okay. So we got lucky on that part. Like the damaging currents didn't flow back and damage the gate drive. That's what I was mainly worried about. Yeah, so a lot of damage. I do have parts to rebuild this just for testing. I don't have these caps here. These are 22,000 or 2200 microfarad. Let's test this one here, for example, see how bad it is. It's, where are we? Okay, it's positive here. And this one measures 7,300 microfarad, which tells me it's damaged, it's shorting, or it's leaking current, and the meter's not picking it up right. So, yeah. Okay, that one's pooched. This one, where's the other one? This one here measures out at 1,800 microfarad. We could still run with this one. It would work, but we're not gonna. I think the damage to these is pretty extensive. Pretty thick cases too. It must have been, well, it was quite a big pop because I heard it when I was next door and I heard a big bang. Anyways, I do have these. These are a little 688 microfarad, 200 volts. I can just pop these in the board for testing purposes, and that'll provide me with enough capacitance just to, you know, get the power supply up and running, and then we can test these, which I also have. I don't have these exact ones. These are high current ones. These transistors are 60 amp at 600 volts. Okay, so yeah, I have some 40 amps at I can't remember the voltage, but it's high enough so I could actually pop some of those transistors I have in here just for testing. So I could put the caps in the transistors, put the bridge back. I think the bridge is okay. I'm gonna run with it again, and then I do have a relay. I found a relay, and that's all good. So I have that in stock. So I have all the parts. I could get this up and running just to test. Now, if I want to order parts, it's going to be about 65 bucks for two capacitors, 2 transistors. Pretty expensive hit on the pocketbook. But I asked him, he wants it fixed because he paid about 500 bucks for this thing quite a few years ago. I don't know what they're worth today, but he's looking to spend at least 200 bucks to get this thing back and running again. He's a welder by trade, and he loves this little welder. So we're going to get it going for him and bring it back to life. So let me get the board prepped. I got to clean some holes, and then I can start populating it with my substitute parts, and then we can run a test and see how it runs. Alright, insulated gate bipolar transistors. Here's a diagram of what it looks like inside. You got a normal transistor, collector emitter, but it has an insulated gate which is not connected. It's not a base, it's a gate, and it's a charge. It turns the transistor on with electrical charge, not through any current that flows. So it's very high impedance gate. It's almost like a MOSFET, but it has the collector emitter, and then it's got a what's it called, a freewheeling diode or flyback diode that's in reverse polarity across the collector emitter. This is just to keep any inductive high voltage spikes from killing the device. So we can test this. Let's get an ohm meter, multimeter, put it on diode check. Let's see if we can check these ones out. Now, let's see here. Pin 1 is your gate, and then we have collector emitter. Like on a regular transistor, collector's in the center, emitter is on the right hand side, and instead of a base we have a gate. Okay. So let's connect between the collector emitter. Let's do one here. Collector emitter. And we have a diode drop. Okay, that's that freewheeling diode that's across the emitter and collector. Now if we reverse polarity, we get open circuit, which is fine. Now, if this transistor was shorted, we would have a short in both directions, okay? We wouldn't be measuring this diode, we'd be measuring 0. And then if we reversed, we'd be measuring 0 again. Now, but this is, looks like these transistors are blown open. We have a good diode and open circuit. Now, the next thing is check between the emitter and base, and we should have open circuit. Now, if the gate was shorted to the transistor, we would have a low impedance or low impedance path, but it's open, so that the gate didn't short. You can check it backwards. Same thing. It's open, so the gate is still fine, which is comforting, because we know that the damage happened inside the transistor didn't flow out of the gate, because the gate is still showing isolation from the rest of the transistor. So that's good. Now, to turn on, okay, let's connect this up this way. To turn on the transistor, we connect up our leads. And we have 0. And what we do is we short the gate to the collector, where I need some kind of tool here. Let's get a screwdriver. And if we short the gate to the collector, it should turn the transistor on, and it's not. It's not coming on, so this transistor's open. And to turn the transistor off, you short the emitter to the gate. And let's try it with nothing there, dead as a doornail. I do have some. Let's try this one. Let's test it out. Open. Reverse polarity. Open. I thought we have a diode drop there. Maybe this one's bad too. Open. Open. Okay, here is a insulated gate bipolar transistor. This is a 30N60A40. Same transistor, but it's less current. So let's try this test out on this transistor and see how well. It should be a perfectly fine transistor. It's just removed from circuit. So if we go here, it's open. Okay, let's go backwards, reverse, and we should see the diode. There's our diode. Okay, let's go this way again. Now if I touch here, it's not turning on. Maybe this one's defective too. Okay, what I did is I changed meters. My digital meter didn't seem to be working. I don't know if it has enough voltage to trigger these or what, but I did a test with this, and it seems these transistors seem to be working. Okay, so let's connect positive here to the emitter and the collector, and right now we have something on the meter. Let me short gate to emitter, and it turns off. Okay, now if I turn the transistor back on, touching gate to collector, it comes on and stays on. So I happen to think this transistor is fine. Turn it off. Yeah, let's try the other one. This can go back in. Turn it on. And turn it off. This one's working too. So these transistors might be fine. Looks like all the damage was isolated to the caps and the relay. Alright, everything's back together, and except for, well, everything's back together. but I have these substitute caps in. These are only 680 microfarad instead of 2200. So I think the best way to test this right now is put it back into the case, connect it all up, and hand it back to the owner and have him give it a try. If it works, I'll order these 2 caps. If it doesn't work, I think we're SOL. I still need to bond this temperature sensing dependent resistor to the side of the bridge rectifier. I can just get a little silicone and slop it in there. But everything else is connected and ready to go. I tried cleaning the back as best as I could. This conformal coating really messes the guy up trying to solder and stuff. You have to take it off before anything works. Yeah, I think this is. I think that I'm hopeful for this. Okay, I got it all back together, and I'm just going to do a no-load test, just to see if everything's integrity's there. Let's just try this out. Let's just go for it. Plugging it in and switching it on. If there's going to be a bang or not. Okay, I think it's working. Just need to shut that off. Now let's pull the trigger. I happen to think this is going to be a winner. So let's, I got the wire speed turned down. Let's turn that back on one more time. And pull the trigger. We're getting action on our motor, and our current draw is going up. Let me measure the voltage on the output as I do that. Okay, I think you can see that. Let's turn it back on again. And we're going to check what kind of voltage we have here. I don't know what it's supposed to be. Let's just try this. 50 volts. That should be enough to weld with. I think this is good. I'll shut this off. What I'm going to do now is I'm going to place an order for the proper capacitors. I'm going to take these test ones out, and then when they arrive, I'm going to slap the new capacitors in, and then I can return this to the customer. Alright, it's next day. Parts have arrived, and exactly what we needed. 2200 microfarad at 200 volts. You know, the important thing, they had several to choose from. The important thing is the diameter. It has to be 30 millimeters so it fits the board, right? That's what you want. So I'll get these soldered in, and here is, I don't know if part number makes any difference to any of you. So let's do this. Now I'm going to, I took the old caps out. These are the test caps. And put those aside, and then these ones go in now. I just didn't want to buy parts without testing it first, because I don't want to throw parts at something that find that there's an extensive fault in it. But this was actually, we got away lucky on this one. There wasn't that much wrong with it, to the point where it wasn't fixable. It was fixable. Let me try. Bending this a bit. Keep the cap from falling out while I solder it. Alright. Iron's warmed up. Here's my solder. Now when you're soldering big heavy traces, you have to hold the heat for a long time. You gotta let it heat soak. We did get them in the right way, yes. Negative, okay. Alright, I'm going to clean up the flux and then we'll put this board back in. And to finish it off, I'm going to silicone these two together. Some generous silicone there. Once that sets up, okay. And I also need to silicone this temperature dependent resistor back to the heatsink here, so I'm just going to spread it a bit with the screwdriver, and then maybe I can get some to squeeze in between the two. And just leave it like that. Let that set up. So here's a look at the parts that went into it. We got a blown relay. The leg is completely gone. I don't know. I should open this up and have a look inside. Maybe it's interesting. I don't know. And two caps that suffered some trauma. So that's all that went into this. Okay, let's see if we can make some sparky. Let's see here. Turn this thing on. Power switch. Okay. It's working pretty good. Yeah, I'm happy with that. Alright, thanks for watching.